This lecture is going to show you how to run basic statistical analyses in SAS. So the point of this course is not to be a statistics course. The point is to show how to prepare data sets so that you can do statistical analyses with them. However, I think we'd be missing a real opportunity if you didn't learn how to do all of the analyses that you've already learned in the first and second stats course here at IMC in SAS. So that is what this is all about. Now, this first slide summarizes all of the statistical procs that do analyses. Now, you can click on any one of these and be brought to the SAS help page on it. So let's just go over to that for a second. These help pages I think are excellent. They give you all the options and you can explore them. So in the navigation bar here, you'll see all of the basic stats procs. Then the more statistical procs will come in if you click on something like proc reg. And so what you'll see is that you have all the statistical procs here, and they're all organized in about the same way. So let's just go take a look at reg. And within reg, what I find often most useful is jumping right to the syntax. And this just lists all the possible options that you can attach to proc reg for running regressions. And you can click on, for example, proc reg and get all the options that you can attach to the proc reg statement itself. All right, so that's how you get help. Now let's have a fairly quick overview of all these things, and I've designed this to be parallel to what we did back in 451 part 1 and what you've done in 451 part 2 as well. So one of the first things that we talked about was standardizing data and finding quantiles. How do you standardize data in SAS? Well, you're going to standardize data using proc standard, and a few things to note about this. We have an input data set. So what I'm going to do here is standardize all variables in the employee data set, and then you must specify an output data set. So we'll make a data set in the work folder called employee. Then two other options you definitely want to know about are mean and standard deviation. So we want to standardize them by making them have a mean of 0 and a standard deviation of 1. Sometimes you just care about mean centering. You don't really care about making them have standard deviation 1. In that case, you would omit the std equal to 1 argument. I'm going to do this for only the age and experience variables in that employee data set. Now, if we run proc means on the resulting data set, so this is worked on employee, notice the mean, sure enough, is about 0 and the standard deviation is 1. So that's how we standardize. What about ranking? Well, we use rank cases, proc rank to rank cases. So let's say I wanted to find the quartiles of the age variable. I wanted to put people into 4 bins. The way I would do this is very similar to proc standard. So I have an input data set, then I have an output data set. The argument that I need to specify to indicate the number of groups is groups. So groups equals 4 means find quartiles, or 4 groups. The other thing that's a little bit confusing about rank is you need both a var statement. So var is going to specify all the variables you want to find the ranks of, and then you need a ranks statement. Now this must be plural. I always have a hard time remembering, is it proc ranks and then rank, or is it proc rank and then ranks? Anyway, you want a rank statement. This is going to create a new variable called age4, which will have the quartiles of age. So let's see what happens. We run this. If I run means of age by the age4 variable, we can see that the first quartile extends from 30 to 39, the second is 40 to 45, 46 to 50, and so forth. These quartiles all have roughly the same number of cases. The reason they're not exactly equal is because of ties. So that's how we find standardized variables and ranks. Let's move on to, I think, one of the most versatile procs in SAS, which is proc univariate. Proc univariate is the equivalent of analyze descriptives explore in SPSS. So this thing does just about every descriptive statistic you can think of. You can specify a whole lot of options, and I've given you a couple examples here. So plot is going to give you a very nice plot with the histogram. It'll give you a box plot, and then it, so you get various plots with that plot option. If you wanted a trimmed mean, you specify the option trim equals and then the percent that you want to trim. And so here we get the trim means. Notice that you get all of your basic moments, so the mean, the standard deviation, skewness, kurtosis, coefficient of variation. You get all the percentiles. A few other options. If you want confidence intervals, you specify the CI basic option to proc univariate. And if we come down, you get an extra section in there, which then gives the confidence intervals as well as the standard deviations and so forth. You can also do confidence intervals with proc means. So the way you get those with proc means is with the LCM and the UCLM options. So that stands for lower confidence limit for the mean, upper confidence limit for the mean. I've also asked for the standard error as well as the standard deviation. So if you remember back from fall, if we take the standard deviation, divide by the root of n, so the square root of 71 is going to be roughly 8 point something. So if you divide this by 8 point something, you get the standard error. Then if you take the mean plus or minus 2 standard errors about, you'll get this confidence limit. All right, so that's how you find confidence intervals. Another thing that proc univariate can be used for is doing single and paired sample t-tests. So let's say we wanted to test the null hypothesis that the average age of employees at this company treating this data set as a sample is 43. So to test that hypothesis, all you do is you add a mu naught, so that is a 0, not a capital O, so mu 0 equal to 43, and then you'll get some additional output that gives you the various tests. So the one that we know from fall was the student t-test of this, and so here would be the p-value. We would reject the null hypothesis that the mean is 43. Just out of curiosity, let's go look at our confidence interval back here. You'll see that sure enough, 43 is not included in that confidence interval. The confidence interval does not cover 43, so we would reject it. So the t-test is going to tell us the same thing. SAS gives us some non-parametric tests which we did not cover. Those are, I believe, in chapter 14 of Siegel, if you're ever interested. So these tests don't assume normality. Let's do the lie detector question that we did back in 451. So the lie detector question was a paired sample t-test. We had all of 6 subjects. We measured their stress levels when they were telling the truth, and we also measured their stress levels when they were telling a lie. And the question is, does the mean stress level for true statements equal the mean true stress levels for false statements? Here's the data. Now, how do we do a paired sample t-test? Remember, the procedure is to compute the difference between them. So take the difference between false and true. I made a new variable diff, and then we will use proc univariate to analyze diff, and I'll add a mu naught equal to 0. So the 0 indicates no difference between the means, and you'll see here is the result. We get exactly the same value that we got back in fall if you refer to your course packet. So that's how we do single and paired sample t-tests in SAS. What about independent sample t-tests? Well, we need to use a different procedure for independent sample t-tests, and that's going to be proc t-test. So proc t-test is parallel to a lot of the modeling procedures. Whenever you have a categorical independent variable, we specify that with a class statement. So let's see if there's a difference in the mean salary level of females versus males. So we would specify the dependent variable in the var statement, the independent variable in the class statement. And so here's the output. Now, just to kind of show how this is really consistent with the modeling routines, proc GLM is going to be a very useful procedure whenever you have categorical variables. So we can analyze this with proc GLM. If you know anything about regression with dummies, this will make some sense. The class statement tells SAS to make dummies for female. So dummy variables take two values, 0 or 1, and we use this for all categorical variables. We then specify a model statement. So salary is going to be a function of female, which is treated as categorical. And then this mean statement will also print out the raw means in addition to the regression estimates. Okay, so that's how we would do an independent sample t-test. Back in 451, the first part, we also did chi-square tests. So chi-square tests allow us to understand whether there's the rows and columns of a crosstab are independent of one another. It also gives us various residuals. So the way we do this is with proc_freq. We have a table statement. The key thing about table is that we're going to put an asterisk between the variables that we wish to cross. So female and training level get crossed. Therefore, we put a star between them, and here's the output. Now, to get the chi-square test, we're going to specify a slash and then a bunch of options. The chi-square statistic is going to be computed because I specified the chi-squared option. So here's your chi-square option. The p-value is not significant, indicating I cannot reject the null hypothesis that training level and gender are independent of one another. Here are some other options. Suppress the row percent, suppress the column percents, suppress the joint probabilities, there's no percent. Expected gives the expected cell counts. So under independence, for example, we would expect 23 males to have training level 1. We observed 27. The deviation is the difference between those two. So if you take 27 minus 23, you get about 4, and that's the deviation. These deviations are not significant. Now back in fall we did adjusted standardized residuals. Unfortunately SAS doesn't do those in proc_freq. You need a special macro, and we'll talk about that macro when we get to that section in a couple weeks.